this PDE with this condition, that is u of x0 is equal to 6 e raised to minus 3x, using this method of separation of variables. So let us start with the assumption that u is equal to xt be the solution of given equation. Right. Then del u by del x, that is x dash t, and del u by del t is equal to x t dash. Now substitute this equation or these values in the given equation, that is this equation, then we get that del u by del x, that is x dash t, is equal to 2 times del u by del t, that is x t dash, plus u, that is x t. Now let us separate the variable by doing some simple calculation. Let us take x common from this side, and this is x dash t. Alright, now let me try x dash upon x is equal to 2t dash plus t whole upon t. Now variables are separated, so let us say some constant k. Next, now we have two different equations, that is x dash upon x is equal to k, and the another equation 2t dash upon t is equal to k. Now for this I can write 2t dash plus t upon t is equal to k, and now this is 1, so I can write 2t dash upon t is equal to k. This is 1 plus 1 opposite side, that is minus 1. So simply I will sub this kind of terms. Two different equation. First equation is this, second one is this. Now let us integrate this term and let us check what we get. So first equation is this, let me write again, that is x dash upon x is equal to k, and the another equation was 2t dash upon t is equal to k minus 1. By integrating we get log x is equal to kx plus c1, function upon function, and the derivative is in numerator, so I can, the integration is log x, and cos k is constant, so kx, and let me write log c1 in place of only c1. Now log, according to the property of log, I can write log x minus log c1 is equal to kx. By simple algebra I can write x upon c1 is equal to kx. Now again I am interested in only x, not log x, so let us write e raised to log x upon c1 is equal to e to the power kx. That's why I can write x upon c1 is equal to e raised to kx, and hence I can write c1 e raised to kx. Now I have first variable x as this. On the other side, for the another equation, let's try to solve this equation 2 as it is. By integrating I can write log t is equal to, this is constant kx minus 1, sorry, not kx, but it is with respect to t, so I can write kt minus integration of 1 is t plus constant, and I will write log c2. So this is log t square minus log c2, this is k minus 1 constant, and t is common. By the simple property of logarithmic, I can write log t square upon c2 is equal to k minus 1 into t. And again I am interested in only t, not log t. I'll take in powers of e. t square upon c2 is equal to e to the power k minus 1 into t. E and log, we know that. What is this? Now I can write t square is equal to c2 times e raised to k minus 1 into t. Now again I am having t square. I am interested only in t. So taking 1 by 2 power or square root on both sides, I can write c2 raised to 1 by 2 e to the power k minus 1 into t by 2. c2 is raised to 1 by 2. Square root of c2 is again a constant. So let me write c3 e raised to k minus 1 into t by 2. Now my another variable is ready again. So finally my answer u of xt is exactly u of xt is exactly x was c1 e raised to kx and t is c3 e to the power k minus 1 into t by 2. So I can write u of xt is equal to c1 into c3 into e raised to kx into e raised to k minus 1 t by 2. Now c1 and c3 are constant. I'll write one more constant as say capital A, and for this I will write kx plus k minus 1 into t by 2. This is u of xt.